everybody. I'm Julie Rizian. I'm at Oregon State University. I have with me Kimberly Ahmad and Ryan Brown. They can give you a little bit of a wave. Um, we have a kind of small group today. We're looking forward to talking about our undergraduate research program that we both ran, researched, and evaluated. And the program has completed, and we have some lessons learned to share with you. It's a small enough group. I'm kind of hoping if folks are comfortable turning video on, just quickly saying hello, maybe where you are in the world, and what kind of role you have with regards to undergraduate research very briefly, since there's a small number. So if you are comfortable with that, would love to see your face while you introduce yourself. Alternatively, you can also introduce yourself in the chat. And Laura, thank you for being our first volunteer. Why don't you go ahead?
Hello, everyone. My name is Laura Gerton, and I teach at Penn State Brandywine, which is primarily a two-year feeder campus in the Penn State system outside of Philadelphia. So I've been at Penn State for almost 25 years, and I've mentored a lot of students on mostly introductory level research projects because I mostly have first and second year students. So helping build their information literacy, getting them just to understand how do you design a question, how do you organize and track your data, and getting them started with research logs. And because we're mostly a commuter campus and students have so many competing pressures, this topic was of great interest to me because I'm always looking for ways to start students early in the research process and find more ways to include more students. So thank you for doing this.
Great, thank you. Lisa and then Melissa.
Good afternoon, everyone. I'm Lisa Brown. I am at Morgan State University in Baltimore, Maryland. I am the director of the Office of Undergraduate Research here. The office has existed for about 5 years now. It started during COVID, so you can imagine just how unproductive I was during that period. But just like each of you, I'm looking for additional ways to get some of our younger students, freshman students involved early on, piquing their interest and keeping them engaged as they matriculate through their time here at Morgan State. I'm going to have my camera off because I'm kind of in two meetings at one time. So
Understood.
Okay.
Hello, I'm Melissa Blanc. I am from Indiana University at Bloomington, and I am the director of our undergraduate research office and run multiple summer undergraduate research programs and am interested to learn about our topic today. Thanks.
Thank you, Melissa. Gregorio?
Good afternoon, guys. How are you? My name is Gregorio Diaz. I am from Long Island, New York, from Farmingdale State College, and I'm the research coordinator for our Research Aligned Mentorship Program. I'm basically in charge of the research experiences and internship for the students for second, third, and fourth year. And basically, I'm here to learn a little bit more about research experiences, and as well as I'm in charge of REUs and all these external opportunities. So I'm really glad, and it's an honor for me to be here. Thank you so much.
Oh, thank you so much. And Sunny has introduced themselves in the chat, and maybe I've met you before, Sunny, at an EPSCoR conference. That's possible. We are hailing from Oregon State University. We don't have any claims of expertise in undergraduate research other than our experiences over the last 4 years running a really alternative modeled program. And so we have generated some practitioner guide and lessons learned for you. And we wanted to share a little bit about what our model is and a few of our key lessons, but also just as an introduction to a broader interactive website we have with the lessons learned. So it is very much if we were to do it again, how would we do it if we had the chance to start all over? And also just some key insights that come from the research and evaluation, and then the experience of running, implementing, and coordinating the program. So I will get us started with share, hopefully. Is that working? No, looks like not working. What about now?
Yes, it's just on a slight delay.
Oh, it's a delay. Okay, great.
You're good.
So our undergraduate research program was called Authentic Research Through Collaborative Learning, ARC-Learn for short. And this was funded by NSF in an NSF IUSE and Office of Polar Programs grant under a Dear Colleague letter that asked the polar science community to address two things. Undergraduate education and the low diversity in the polar workforce. And so looking for some additional pathways into the polar workforce, both the academic and non-academic polar workforce, and the data-rich environment of the Arctic. It's been pretty popular to fund gathering of new data and less popular to fund processing and making meaning from the data we have. So that combined with the National Academy's report on undergraduate research experiences that recommended looking more into ways to provide more access to undergraduate research, and in particular trying to better understand wraparound programs and the opportunities there, along with some of the work out of University of Wisconsin for research readiness. We were looking at the research readiness course developed at University of Wisconsin that was sort of a precursor to an undergraduate research experience, and we thought it might be nice to put these two things together. And then finally, I want to say we had our own observations. My co-PIs, Lauren Juranic and Miguel Goni, who are both polar scientists, both focused on the Arctic. And I had done a lot of field experiences for teachers and for students. We all had this high romance associated with our field experiences. And when we started talking about access, our ideas for creating access were all about the model of what we found sort of romantic about science when we were young and not accessible to others, right? So we really tried to challenge ourselves to get kind of past our generational privileges and preferences and think about what are the things about our field that are actually intimidating, exclusive, and sometimes unsafe, at least in perception and the feeling that they invoke. So those things all together led to ARC-Learn. Okay, let's see. So I've already kind of given the introduction. We're going to talk a little bit about our model, and then the practitioner guidebook. We'll just highlight a few themes from that, and we hope to keep plenty of time for discussion and Q&A. Oh, turns out screen sharing and changing slides for me is more than I can handle. Okay, here we go. So our model was really kind of ecosystem based. We were thinking about our observations of undergraduate research experiences and how variable they were and how much sometimes students were sort of just treated as an extra body in the lab or an extra body in the field. And sometimes the focus wasn't as much on learning outcomes for students and trajectories and persistence for students, and then just overall development and growth for both students and mentors. We also knew that mentors often didn't have any training, didn't feel comfortable sometimes with mentoring skills, and generally felt like they didn't have the time to do that. So we this came to be as a design-based research program. So we were building the program, running the program, researching the program and evaluating its effectiveness all at the same time. We're happy to answer questions about the pluses and minuses of doing that as well as the details about the program. So it had lots of different features you can see here, and I'll talk about those a little bit more. So the ARC-Learn model is long in duration. So instead of the typical 10 to 12 weeks, we engage with students over 2 academic years, 18 and 18 months. It was lower intensity, so instead of maybe 30 or 40 hours a week, we were only expecting students to engage about 2 hours a week, and we spread out our learning objectives and curriculum over the course of that 18 months. We also really wanted to build community, just like traditional REUs do, but it's a different task when you do it in a low intensity way. We required no field work. In the polar sciences, field work is it's not for everyone. It's not, and it's also not the majority of the actual work that's needed given this data richness and the lack of capability and capacity to do the meaning making with all the data. We were very much thinking about students who have caretaking responsibilities, who have non-traditional enrollment patterns, who have the types of commitments in their lives that mean going out into a remote field location would be highly disruptive for their life. We wanted students to not just drive the program for themselves, but also spend time interrogating what does interest them, what gets them excited about science, and where do they want to put their energies. We had peer teams, and the mentors worked in groups as well. And we provided a course-based credit and non-credit options to make a more kind of financial accessibility for students, but also students could get their required experiential learning and internship type credits through our program, which just was a collaboration with our college. And we provided stipends so students could have access to things like childcare or time off work and still be able to participate in our program. So the goals were to increase access, also utilize this data surplus, this data richness of the Arctic environment, invite students into a scientific community. So it wasn't just as an apprentice or as in a short-term way, but really into our college's community of polar scientists. Provide inclusive mentoring training for mentors, and we based that off of work that Sophie Pierzalowski did and has presented to the CURE community multiple times, to provide some source to diversify the polar science field and workforce, and then evaluate, examine, and share out our design principles and how they worked out. We ended up with 2 cohorts, and we did the first time we were so student driven that it left some people untethered, and so the second time we really assigned mentors to thematic areas and then matched students into those thematic areas, and then did the student driven research emphasis and question design within those thematic areas, and we're happy to talk more about that. We had cohort-wide sort of all hands meetings regularly, and then the teams, which would include a few students and 2 mentors usually, though they met additionally. And then the mentors were in a community of practice peer learning environment every month or every quarter, sorry. And students, again, using existing data to answer polar research questions and then presenting their findings at an undergraduate research symposium. And so we did that in a couple of different ways. They first presented just with a small kind of in-group, people who were friends of the program or interested in the program from our STEM Research Center, College of Earth, Ocean, Atmospheric Sciences. And some of their mentors and their mentors would bring colleagues in. So we did that at sort of a small scale, and then we scaled it up to a more public audience. When we initially designed the program, I will say we had designs on having students engage with public audiences outside of the academic institution. And we ended up scaling that back because the students needed so much development time in the research readiness space that there wasn't really space to do that well. And we learned that pacing the students appropriately was hugely helpful for their success. So we had staggered cohorts. So at one time we had 2 cohorts overlapping, and that created a little bit of additional community. We also had students online in the first cohort. That was because of kind of carryover from the pandemic. In the second cohort, we did that in a much more intentional way where we had a group of students online working together. And that was really successful. And then, yeah, we've been sharing out our lessons learned, and today is part of that. Okay, so we have this practitioner guidebook. You can get to it through this QR code or through this link on this page. It is a free online interactive resource. There is also a PDF if you ever needed a citable version or a document to share. That's there for you. It is our lessons learned, things to consider when designing undergraduate research experiences, especially if you're kind of thinking, let's go out of the box. Let's see how we could address accessibility in a different way. Let's see if there are other models that might work better to integrate with courses, for example, or with our organization's other goals. And this is really for our peers, people who might be coordinating or spinning up programs like these. And we hope that you find some of the themes of interest, and we'll go through just a couple of them. Okay, so one theme from our program, ARC-Learn, which was intentional, authentic research through collaborative learning. But we also really emphasized the whole arc of research. We had, like I mentioned, observed students just doing data cleaning all summer long in an REU sometimes, or just collecting CTD data all summer long without really understanding what that data was going to be used for, what questions were at play, what were the other parts of this whole scientific process that they were missing in their really concentrated experience. So we wanted students, like I said, to interrogate their own strengths and interests, and also to understand what are realistic research questions. That gave the students a lot of agency and ownership over their own projects. They were also had the opportunity to show their resilience. For example, if they needed to use a coding language or an analysis platform that they weren't prepared to use with a long duration, they could go take a course or spend 2 months in a mentoring relationship spinning up on that platform in order to apply it for their own project. So that opportunity to identify a problem and then figure out a way to push through it and come to the other side was really enabled as part of the long duration. And what we found for the students who completed the program is incredible sense of self-efficacy and agency. One of the favorite things that a student said that was shared with me was that I didn't think I could be a scientist. And then halfway through this program, I realized I am a scientist. I am being a scientist. And that to me is a really kind of special outcome. We definitely had challenges with data. Data is messy. Data is often non-compliant. Data is often missing in incredibly important metadata. And the students were really had to work through that and kind of come to the reality of understanding that the data is just imperfect that's out there. And you kind of have to figure out what questions you can ask rather than what questions do you want to ask. Sometimes the mentor expertise was a little bit mismatched with the student interest, and that required some pretty big mindset shifts from mentors. And we were asking them to guide students through the scientific process rather than be the go-to expert in a subdisciplinary field. And we needed a lot of scaffolding and timelines and clear expectations. The coordination of a program like this that takes course over 2 years really required a lot of that. Another was just the duration and intensity. I mentioned there was online students. We supported students in kind of being flexible about their work and caretaking responsibilities. One thing that's interesting is you might not look at a group of our students and realize that they had accessibility challenges, but they all had stories. They all had windy paths that got them where they were for the most part. And they all didn't feel invited. When we asked them why they applied to the program, some of them said things like, well, you explicitly invited me by telling me this program is for people with other responsibilities. We talked about the time to gain technical skills and that flexibility. It was challenging to keep students on pace. We have a 10-week term here at OSU, so they went through the course of a summer and 6 10-week terms, which means almost every week there is some sort of academic crisis. First week of term, midterms, finals, big paper due. And so keeping this long duration thing going in the background the whole time was really hard for some students. And it required a lot of scaffolding from us. And obviously advanced planning and commitment, not just for our team, but for the students themselves. Making time to spend a few hours in data analysis when you've got a final that week is a really hard thing to do. Okay, finally, the inclusive mentoring. I mentioned Sophie Pierzalowski's work, and she has, I'm happy maybe one of us can find it and share it here too. If you haven't seen her online interactive training for inclusive mentorship, it's a really great resource. She's got a couple of accompanied scholarly documents that go with that too. But this was great for mentors to gain new skills. We found that people more experienced in their career had a harder time making the mindset shift to this kind of mentoring. And we found that near peer mentors were really great resources, postdocs, and in some cases, PhD students. But overall, the students felt valued and supported by mentors. They gained relationships with mentors. In fact, the student pictured here ended up working for one of her mentors later and is actually still from our first cohort, still on campus, I believe, still working in the science space. Mentors did need a lot of reassurance that doing this type of intensive and engaged mentoring work would not count against them in their promotion packages, and in fact would be perceived as a positive. I hate to say that that's a reality in a lot of universities, but it certainly still is a reality. And they just had to get outside of their comfort zone. And it was hard. The peer support was really important for that, but we would have liked more time to kind of build a culture around getting outside of your comfort zone. All right, final slide, key takeaways. It is possible to break the traditional model of URE and build something different. And if you're doing that, we hope that our guidebook will give you some things to think about and considerations for how you do it. We are not necessarily advocating that any particular design is better than another, but just that there's lots of things to think about when you move away from tried and true models. And yeah, we just hope that the insights are useful for you, and we want to open that up for questions. I'm going to stop share so I can see what's in the chat. Oh, thanks, Ryan. So in the chat, Sophie Pierzlowski's work, and she was a fellow for Advancing Research Impacts in Society when she created that work, is available to you. All right. Maybe I'll start with, as people are kind of warming their way into questions, if Kim or Ryan have anything to add.
Yeah, thanks, Julie, for the overview. It was I was kind of on the project to handle some of the research components and evaluation, and I think that this resource guide and learning from the lived experience of going through this program and getting the chance to talk with students and mentors and everybody who was involved is just a great way to kind of share in a community way, in an accessible way, some of the considerations as Julie outlined. I hope you take some time to peruse it and see how it applies to your own work.
I do have a question, Julie.
Great, yeah.
First of all, thank you so much for sharing all these, a lot of insights and writing down some things, so I appreciate that. So maybe two questions that I have. I think the first one is related to the faculty mentorship or training mentor. Can you maybe explain a little bit like how does it look like? So who mentor the mentors or who mentor the faculty or how the program looks like? And the other question that I have, I think was related to, oh my goodness, I'm just thinking the other question that I have. Oh yeah, so this is science kind of related, right? This program, like a STEM related, right? Because Okay, because you were mentioning about that there is no lab experience required, and it's a 18 months program. So so if the students are working on a research science related, how that 18 months look like without, let's say, without any lab experience? It's a little bit hard for the students, just be on maybe just based on papers and articles and not going to the lab. Just, but that's
Yeah.
totally normal, and I think we can do that, but just have the experience from the students not going to a lab, for example.
Yeah.
But those are the questions that I have. Thank you.
So for the mentors, we actually brought Sophie in to do the training. So that was a fantastic partnership. that we had. She's at University of Washington, but she had formerly been here at OSU and run an undergraduate research program actually in the same college where we were running this one several years earlier. Hers was focused mostly on marine mammals, so a different space. So we hired Sophie to do the training, to use her modules, and had the mentors go through the training. And then we relied a lot on the peer learning community format for mentors to bring up their challenges. And we facilitated those conversations lightly. We were really hoping that mentors would support mentors with their experiences. So I'll just say flat out, with such a small group of mentors, 10 mentors per cohort, a couple of voices who feel really strongly about certain aspects of mentoring or have some really traditional ideals around mentoring that may or may not serve all of our students, can have a pretty big impact when you rely on a peer learning community like that. So that was something for us to manage. Another aspect of the mentors was getting the academic affairs folks within their college where they work involved to make sure that they were on board with them spending their time in this way. If you mentored in ArcLearn, you couldn't necessarily get report as high of number of students maybe, because they're not quick turnaround mentorships, right? It's a long-term engagement. So for that question, and then in terms of the No Lab, we really focused on data literacy. In terms of our learning outcomes, are really focused around polar literacy and data literacy. And so we had labs, so to speak, in the computer lab where we were learning about different analytical platforms and different coding languages. And then the students, based on what types of data work they needed to do for the question that they had, we hooked them up with mentors who are willing to help them through that. And that may or may not have been their own team mentor for the program. We were lucky to have a few people with a lot of technical skills and a lot of generosity of spirit involved to be able to do that a little bit more. Ryan or Kim, do you have anything you want to add to those?
Maybe just a point of clarification. So when we keep talking about data surplus, we're really talking about there are these big data sets available, publicly available, data that's been collected out in the field by Arctic and Antarctic scientists, whether it's water salinity or erosion patterns. And so there are these big databases that our mentors were familiar with, and basically helping guide students to access the right databases that would help them answer their questions. And there was definitely a lot of literature review involved to help with the content knowledge, but also like mentors guiding the students in finding the appropriate data and kind of cleaning the data sets. And so that's might be considered more of that lab work component.
I might say one other thing about the mentoring. So the training platform that we used with mentors, it really addresses like power dynamics, and it asks people to really confront sort of gatekeeping practices that are quite common in certain STEM disciplines, acknowledging kind of whole person, which when you're with a student for 10 weeks, you don't really have to do that. You can kind of get away with just being like, we're just doing the science that is in front of us right now. When you're with a student for 2 years, their whole life spills into the program. So that was part of it. And then also we worked with mentors to really show their vulnerability. So we asked them up front at the beginning of the cohort to give a little speech about their windy path to where they got in science, because it can be so easy to, as a student, to view every scientist as somebody who had this straight path ahead of them and all they had to do was put one foot in front of the other. And for some scientists, that's been very true. But for many, they worked in industry for a while. They weren't sure what they were going to do. They dropped out of a master's program at some point. And we asked them to share that, those experiences, that kind of windy path and the insecurities and vulnerabilities that they feel. and how just because you choose to do one thing for a master's degree doesn't mean that you've selected that for the rest of your life, those kinds of things. So we ask them to show up as humans as much as possible.
Thank you so much. That was very good. Thank you.
We are ready. Feel free to also throw questions in the chat if you have them. Lauren, or
Hi,
Laura.
I have a question, and hopefully you haven't faced this, but my background is geology and oceanography. And so when students want to do research with me, or I talk about doing research, they do want to go in the fields because in their minds, it means going outdoors and going to the beach and things like that. And so when I talk about data type projects, we've got amazing data. We've got samples right here to work in the lab. They're so disappointed. And some of them don't feel like that's research. That they're like, no, I want to do a research project. I don't want to work with data that's already there. So have you faced that? Now, how do you kind of promote to students that, hey, this is a real contribution. This is so valuable and just as important as if someone was going in the field?
Yeah, we absolutely faced that in a couple of different ways. So one of the things we tried to do was we had travel funds, so students could also get to a conference and present. So they could sort of express their contribution to research in that way. Not all of the students were able to utilize that. Actually, that was something that that's part of that accessibility. So some of those same students who had childcare, elder care, or the types of jobs that they couldn't just say, "Hey, I'm out for 3 weeks on a ship." They appreciated the opportunity, and then in particular, our eCampus students appreciated the opportunity. So we had positives. We had some students who I think left the program for other research opportunities that maybe included field or some other more traditional lab time. But yeah, I mean, it was us really saying, hey, this is a problem in science. Is there's not enough people with the data literacy skills to utilize the work. And we shared that with the students. We shared our rationale with them. Some of the students also did get the opportunity to go to the field either after their program or in the summer in the middle of their program. Not necessarily with their own mentor, but there were other opportunities that came up. So we tried to make those opportunities available without having them be a required feature of the program. I'm not sure if that answers your question, but we did a lot of reflecting as a PI team of our own biases about that science can't be done if you don't go into the field. Well, it's just simply not true anymore because of the modalities that we have to collect data. And I think I still get like that nostalgic feeling when I think about my fieldwork time, and I still have that like a little bit of a gatekeepy personality of, oh, maybe you really can't do science without this. But science has evolved, and we have to be willing to allow people to be scientists when that maybe isn't a real part of accessible part of their life. So yeah, Kim or Ryan, anything else?
Well, I would just emphasize the value of the program for the eCampus students who were involved. So with our second cohort, we really intentionally created a team that was just eCampus and remote students. And they wouldn't have been able to participate in a research program any other way. And they actually formed really tight bonds. They formed community with each other, their mentors. They have long-term relationships with their mentors, and so that was like a really big success, I thought.
Yeah. And Ryan did an amazing job, went kind of above and beyond to do these integrated all hands meetings so we didn't separate the virtual students out. We had these meetings all together, and they presented just like any of the students in the room with our all hands meetings. Most of our all hands meetings were like there was some skill development or some presentation of benchmark progress that they gave to each other. So over the 2 years, the students, both online and in person, got to know each other's projects, and it was really fun to see them giving each other feedback and also being excited to, oh man, 2 months ago you presented this and I was super confused, but now I get what you're doing, and being able to see that progression. It was really rewarding for sure, as a program person, to watch that. And those students, like, I still see them around campus. Some of them are still here, see them around campus, and they stop and check in and all that. Where, a lot of these traditional programs, they come in and they're gone, and you never see them again. Maybe you get asked to write a lot of reference letters, but you don't actually have a lot to go on for a reference letter after a 10-week program.
I do have
To
another
your
question, Julie. I'm sorry.
oh,
I'm
no,
sorry.
go. No, go.
Because I'm hearing all these comments from Laura as well and Ryan. I think building that community is very important as well. And how's the retention of the students in terms of, like, because 18 months, maybe one of the students is like, oh well, I'm gonna be in this research for 18 months to 2 years. Like, how do you retain that student? I assume that probably the program is gonna be, you have to be, you are required to do this program during the whole 2 years. But how do you retain the student that they
Yeah.
don't get bored, or it's like, or maybe building that community that you said, like maybe events, or you know the
Yeah.
retention, I think, is very important.
So we have, if you just do the math, you have higher retention in a program like this. More life happens in 18 months than happens in 10 weeks. The other thing is, we had a lot of transfer students. That was a target audience for us. And then, like we've mentioned, a lot of students with other outside responsibilities that maybe our idea of a traditional student of a traditional age and of traditional means for college doesn't have. So our attrition was high. I'll say that. We did exit interviews, and I'll let Kim talk a little bit about that. We really wanted to understand for each individual student exactly the circumstances. And there was a variety of circumstances. For the most part, they were like things like financial or familial circumstances. This was an area of discussion with NSF, our attrition. They were like, how come there's so much attrition? And we luckily had somebody from a community college on our advisory board who had done these bridging programs before, and has just been a community college educator for a long time, and is part of the SAGE network, which is a really fantastic network of folks. And he just said our retention's actually pretty good when we consider the students. These are we took a lot of students who were kind of like unlikely to graduate. If you look at comparator students, our hope was that a few more of them would graduate because of the program, and that we didn't. I'll say I tried really hard. I was a little. I wanted to control the attrition rate more than was reasonable, because ultimately people flow in and out of STEM, and it's not a pipeline, it's a river. We use that model and with our mentors too, and talking about it, the braided river model. People are in and out as their life makes it available to them. And if we were to build it so rigidly, a lot of people would never come in. And that's what we wanted to avoid. So yeah, ultimately our attrition was high. Kim could probably tell you the exact numbers because she's spent some time with that if you want it. And we also we did publish our evaluation reports. And so we get into the weeds with the things that went well and didn't go well in those reports. And you're definitely welcome to download those. And we just really tried to take it not as a failure, though, as like we are providing something for the students who can participate for the time that they're able to participate.
Yeah, also as Julie alluded to, that it's actually one of the things we suggest in the guidebook of, okay, maybe 2 years, maybe perhaps that was a bit too long, because like even the mentors don't know their schedule that far in advance, and sometimes field work pops up and you have to speak for the mentors and they had to be gone for
Or some of them, we had mentors leave the institution during that time,
Yeah, exactly. So we definitely have reflected on that a lot, and might suggest slightly shorter duration to make it more manageable for students and mentors. But I will say Ryan did incredible work to really strengthen and foster community within the cohorts and actually across the cohorts too. And so Ryan might be able to speak more to those kind of the hooks, the engaging aspects.
Well, one of the things I was going to mention is we really intended the program to be as flexible as possible for students and their other considerations. So there was a really fine line between making it structured enough so people knew what they needed to do to be successful in the end, and allowing enough flexibility so that when things came up in student lives, we could work with them and find alternate ways forward. So I can think of a couple instances in which we just kind of we didn't change the ultimate goal. In fact, we just kind of helped them work to figure out how they were going to catch up. And there were some students that did stay with the program because we were able to work around what they needed. That didn't work for everyone because there is still the ultimate goal that we had to get to. And some people, like Julie mentioned, left their majors or the university or other things too. So yeah, so that flexibility was a key component.
I think also with the mentors, just like acknowledge that whole person, right? Acknowledging that in the course of 2 years, people get divorced, they lose loved ones, they lose their jobs, like all kinds of things happen to people in the course of 2 years. And it is a bit of it's ambitious, right? To think that we're going to create flexibility, maximum flexibility. And I will say, we had the luxury because we had some NSF funding to do this, that we could talk about every single instance of attrition as a whole team, including researcher, evaluator, all PIs, and mentors. And there was at least one, but Ryan, there might have been 2 or 3 instances where students dropped off the map. And because we are in this 10-week term, right, there was nobody that noticed except for us, because those students were in our ecosystem for a long period of time. And we could say, what happened to this student? We could call the advisor and say, have you seen this student? And the advisor say, actually, they canceled their last 2 appointments. We could call, we could start to track it down. And in one instance in particular, that gave us the opportunity to be available to a student that had really become quite untethered and needed extra support. And so I know that like from a business model standpoint, that's not realistic in most cases. But there were definitely parts of our conversations were like, well, if in that one instance, we kind of were there for that student in a way that nobody else could have been there for them, that kind of makes it all worth it. But it is a bit of a dream to be able to give that much individualized attention to students over this period of time. And we did the advisors, their college advisors were also involved in the program, which was super helpful.
So thinking about the student-centered topics, were there main categories that the issues fell into? Like the questions weren't ambitious enough, or they were too unfocused, or they weren't novel enough? Like, were there buckets that we could work through?
I mean, one theme that stood out to me, but it's not the only theme, so I'll let others chime in as well. The theme that stood out to me is that our students, I mean, this goes like across the university, undergraduate students are so altruistic. And I know there's science about kind of the altruism of STEM in undergraduate students. They just, I think, came in with these ideas like, okay, well, first of all, they're gonna let me do science. Second of all, I'm pretty sure I could solve climate change or something big. I have this energy and I have the will and the desire, and I'm getting the skills. And they kind of had, I'm being a little hyperbolic here, but not too much. They had to kind of get through the grief that comes with understanding that science happens in these very small iterative ways. And really what they might be doing is defining one edge of one puzzle piece in a 5,000 piece puzzle about loss of ice in Northern Alaska, like they kind of had to come to terms with that. And I would say that happened, Ryan, I feel like that happened kind of like term 2. So we're maybe like 4 months in when those things start happening and they're defining their research questions and we're having to kind of focus them in a little bit. So that was a theme that stood out to me. There were also other themes that had to do with data availability. But Ryan, do you want to add anything?
Yeah, I was going to say that process started in term 2, but it didn't really end until like term 5 or 6, which was the end of the program. So it was actually a really long iterative process for some students of getting themselves to a research question that they could answer. There was one student, the first cohort, who actually changed his question the night before he printed his poster for the poster session. But it was still valuable for him because he'd gone through the entire process to get there, right? And he had found and analyzed data to answer quite a few different questions. Yeah, I would say that very few people got through the program. I don't know if anyone got through the program without changing their research question. And I think there was like a couple themes. One was that the question was just too big and they had to narrow it and narrow it and narrow it to something smaller. And then I think the other one was that they would ask a question and then the data that they needed didn't exist, or it existed in some form that was completely unusable, either from the data's perspective or from the skills that they had to work with as sophomores and juniors, undergrads. And so they would need to shift and ask a question that was more in line with the data that they found. So that was frustrating for a lot of students, but the fact that they got through it, that they got through all the steps of the scientific process, was really, really, really satisfying.
I definitely took that experience, watching students go through that experience. Well, it's super reflective on your own development as a scientist as well. But I also really felt at the end, like those students who went through that process and struggled through it, like they're so graduate school ready. Um, they're so ready to adapt in the ways that you need to adapt as a graduate student. And they don't have any illusions that science is a very clean and orderly process. So generally it's not.
And talk to me briefly about branding and marketing, because we're doing this alternative model to reach potentially students that wouldn't be able to do the normal model or the traditional model. So like, I guess you could create something that allows for them to come, but is there a way that you then specifically targeted those students to let them know, hey, the water's safe now?
Okay, so it was a bit messy because NSF did the thing where they waited to tell us if we got the award until like the week before we would need to actually have students at the table. And we asked for a deferment so we could do that work. And they said, nope. And so we pivoted. We used advisors. We went to advisors and said, here's what we're trying to do. Are there any students under your umbrella that you can reach directly out to and say there's this opportunity? We also cast a wider net and we went through our office for undergraduate research and had them advertise, and we put a website up. I think that's true, Kim. We put a website up right away and an application process. Like we got the grant and 2 days later we were like getting that stuff up and going. And the application, the invitation to apply, it spoke directly to students. It wasn't like you had to be nominated by a professor or something. You didn't have to have that inside track to do it, as many other programs sometimes do, especially ones during the academic year. And then we just said, if you have a job, you're a transfer student, you see yourself as underrepresented in science, you have non-traditional enrollment patterns, and we described what that was. This is for you. We just said that outright. I'm not sure that we could say the same thing now that we did then, but that spoke to students. Students saw, we wanted them to see themselves in the invitation. And we did have we got I feel like we had 48 applications that first year, which was shocking to us. And we were able to look at them in not based on um, are these the students most likely to go to graduate school? Our numbers could look really good if we maybe did differently, but this was a research program. We were trying to understand students who maybe wouldn't have otherwise had access, what their experience would be in this alternative model. So we were looking, of course, for students who were able to describe those life circumstances that would normally exclude them from a program, undergraduate research experience program. Todd, does that answer your question?
Yes. And Ryan, thank you for the link. That's very helpful as well.
Yeah, that was the information that we prepared at the beginning. That was kind of the basis for some of our outreach.
And then my final question, we're seeing a rise in students that mark interdisciplinary in their presentation options for NCUR. I'm just wondering if you could imagine this model, like would it fit well with social sciences or the humanities? Like, could you imagine a very similar model working well across disciplines or in other fields of study as well?
Yes. And if we had had a year runway to get that buy-in and build like interdisciplinary mentor teams where the themes could be human dimension inclusive, I think it could work. I think you need a lot of I think you would also need to train them at mentoring mentors beyond inclusive mentoring practice, also in interdisciplinary team practices a little bit more. We actually did open ours up, and we had initially a student from the College of Liberal Arts involved, and ultimately that student could not see themselves succeeding in the program, and they weren't wrong about that. We did not have the right infrastructure and mentoring team to pull that off. So yes, I think it'd be great for interdisciplinary as a model, especially because of community building. I do think academia needs to catch up a little bit though, because there isn't necessarily a trajectory for those students who dive into the interdisciplinary space so early in their science career and their science investigations. There might not be a home for them as many. Might not be as many homes for them as there are for students who are in more kind of traditional, physical oceanography, biological oceanography kind of spaces. Ultimately, this program was it would have required just a lot more administrative leadership to be involved in order to do it really in a cross college, out of silos way. And doing things like working with the advisors and all that, keeping it within one rather large college, but still one college, really helped us support the students better.
I think we have time for another question or two. If anyone has some, you can put them in the chat or just unmute yourself. Otherwise, the website really is a gorgeous website, the PDF as well. So much useful information there. That link is in the chat. For those of you watching this video, the link will be in the bottom of the YouTube notes as well, description. So please check that out and benefit from their paving of the way of this alternative model for URE. And if you have any questions, I think there are contact information at the bottom of that web page, so you could reach out to the proper people that way. Otherwise, thank you so much, Julie and Kimberly and Ryan. Your work is wonderful. Thank you for sharing that with our CUR community, both those present here today and those of you watching this webinar online.
I do, Todd, if I can just give a quick shout out to our colleague Jessica Sawyer, who really helped us conceptualize kind of interactive version of a guidebook and actually made the technology work for us and had supported some of the communications around the program too. So, and along with our co-PIs who I mentioned earlier, Lori Jaranek and Miguel Goni, both from Physical Oceanography, Polar Sciences.